Experiences are what people love the most about travel. Viator is a website and app where you can book travel experiences like hiking Mount Kilimanjaro in Tanzania or enjoying the views while cruising on a catamaran in the Caribbean. They offer everything from simple tours to extreme adventures. With over 300,000 bookable experiences in 190 countries, there's something for everyone. Plus, Viator's travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. When you book a travel experience with Viator, there's always flexibility and support with free cancellation, payment options, and 24/7 service. Download the Viator app now and use code Viator10. That's Viator 10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you for joining us on the podcast we call Space Nuts. I'm your host, Andrew Dunkley, and joining me as always, astronomer at large, Fred Watson. Hello, Fred.
Hello, Andrew. How are you doing?
I'm very well, thank you, sir. How are you?
You don't have to call me sir. It's quite all right.
I always like to be polite to seniors.
Thanks a lot. Well, yes, I'm very well. Considering how senior I am, I'm doing pretty well. Thank you.
Dear, I'm getting very close to that myself, so I've got to be careful. It'll come back to bite me one day.
Now, round two.
Yeah. Now, Fred, some interesting and fascinating and somewhat bizarre stories to talk about today. First of all, the 7-year mission to Mercury. This sounds rather ambitious. And why Mercury? I'm sure you'll be able to tell us that. But this other story that we're going to discuss is just out there. And, you heard the phrase only in America referring to weird news. Well, now I think it's only in China because more weird news comes out of China and the subcontinent than anywhere else these days. And this one has got to be right up there, almost literally. China is considering putting a fake moon into orbit to brighten the sky. No, is it fake news? We don't know, but we're going to talk about it anyway. And we've got a couple of questions we're going to deal with from Scott, who wants to talk about asteroid capture, and Michael, who wants to look at rescuing astronauts who are stranded after a failed liftoff, which happened the other day, Fred. So we'll get into those. But first, this 7-year mission to Mercury. What's the story behind this one? This looks like a joint venture approach.
It is. That's exactly right, Andrew. It's a joint project of the European Space Agency and the Japanese Space Agency. And in fact, it's more than a joint project because it's actually a joint spacecraft. There are 2 spacecraft involved here. Technically, there are 3, but one of them is the sort of propulsion module that gets the other 2 to the planet Mercury. So this is a kind of follow-up of the Messenger mission, which was in orbit around Mercury a few years ago, a NASA mission which taught us a huge amount about Mercury. But like like most space missions, it raised more questions than it answered, including some very interesting questions about the magnetic field of Mercury. Messenger also was a bit limited in the shape of the orbit of the spacecraft around the planet Mercury meant that it was really only the northern hemisphere of Mercury that could be mapped in detail. So there's still a lot of Mercury that is not unexplored so much, but certainly not explored in as much detail as the Northern Hemisphere. So the Bepi-Colombo mission is designed to answer as many of those questions as possible. Its name, by the way, comes from Actually a scientist, not a politician or anything like that. It was a mathematician and basically a space engineer. Worked at the University of Padua in Italy. His name was Giuseppe Colombo. His nickname was Bepi, and Bepi Colombo is the name of the mission. He was born in 1920 and lived until 1984. So it's honouring a past master at orbital dynamics. And the reason why he's celebrated in this mission is that he was especially interested in the orbit of Mercury, did a lot of work on how you could get the spacecraft into orbit around Mercury, but more especially, he was the person who first implemented the idea of a gravity assist. You know, when you fly by a planet and pick up some of the momentum of the planet to gain energy.
Which is what they did to with the Voyager missions, because
the
there's
Voyagers,
no way they could have travelled that far on fuel alone. Yeah, that's fantastic.
Yeah. So I think the first spacecraft to use it was actually earlier than that. It was in 1974. It was Mariner 10. And that used gravity assist. But gravity assist will come into its own with the Bepi Colombo flight to Mercury, because paradoxically, when you fall into the inner solar system and try and rendezvous with a planet like Mercury, you need huge amounts of energy. You'd think, oh yeah, you just kind of let the thing drop towards the sun, but it doesn't work like that. You've got to lose the energy of the Earth first of all, and then you've got to catch up Mercury, because Mercury is moving much more rapidly in its orbit than the Earth is, because it's closer to the sun.
Yeah.
So this flight involves no fewer than 9 separate flybys, 1 of the Earth, 2 of Venus, and 6 of Mercury itself. So these are all gravity assist things that are effectively, getting the spacecraft into its orbit around Mercury. And the bottom line is, it doesn't get there until December 2025.
Because of all this effort, all the mathematics behind it to make it get there, catch up to Mercury.
Yeah,
that's
indeed,
just amazing.
Correct.
Yeah, I was hoping that they were going to fly by Mars, because a lot of spacecraft do slingshot around Mars, and it's going to set up a cafe, but no, it's not going to work.
Probably not quite, but it's certainly, notwithstanding it's the fact that it neglects to visit your favorite planet, Andrew, it's still pretty good going.
Yes.
So it was launched successfully on Saturday. That's the 20th of October. It is on its way with a 7-year cruise phase. It's basically designed to have a 1-year science phase, which will probably be extended, as they nearly always are when they're successful. The 2 separate spacecraft entities to this are, first of all, the planetary orbiter, which was built by the European Space Agency, that will essentially study the surface of the planet. It gets to within 300 miles or 480 kilometers of the planet's surface at its well, what do you call it when it's Mercury? Perihermion. Oh, there you are. There's a nice word, because it's Hermes.
Remembered that.
Yeah, Mercury, perihermion. 480 by 1500 kilometer orbit. But the other one, which was the one constructed by the Japanese Space Agency, is the Mercury Magnetospheric Orbiter. And that's all about investigating the magnetic field of Mercury. That's in a rather bigger orbit. It will stretch further out. But the 2 will, they're both in polar orbits. That means that they kind of both cover all parts of the planet's surface and all parts of its magnetosphere during their orbital periods. And they're going to be complementary. So I really quite like the idea that if one of them finds something really interesting, you can get a different perspective on it from the other one, get a different view, because there are these two spacecraft.
Cross-checking.
Yeah, that's right, cross-checking. So there's a thing called the Mercury Transfer Module as well, which is the propulsion unit, which essentially deals with the voyage to Mercury. That's jettisoned when they get into orbit. But just one interesting thing about that, it will use ion propulsion. So it uses, electric propulsion rather than chemical rockets.
Wow, that's really amazing.
Yeah, it's neat stuff. There have been a number of spacecraft that have used that. for example, I can't remember which one it was, one that went to the moon that used that. The ion propulsion system gives very low amounts of thrust, but it gives it for a very long time. So you build up quite significant accelerations.
So it just keeps on going. So they're basically going there like we always do to have a look. But but because of previous missions, we have questions that need to be answered. So we're going to try and fill in some blanks as well.
That's right. So there's, the stuff that I think we'll be particularly interested in, the fact that we believe there is frozen water in the poles of Mercury, the deep craters of the poles. There was certainly evidence of that in the Messenger mission, which, by the way, ran between 2011 and 2015. That's when Messenger was in orbit around Mercury. You and I talked about it several times. Because of the orbit of Bepi-Colombo, it's going to look directly down into those craters near the North and South poles. So that will be a very interesting thing to do, to investigate directly what the amount of water ice near the polar caps is, what it's,
it still blows my mind that something with such an incredibly high surface temperature so close to the sun could have ice in it.
Yeah, it is slightly counterintuitive. That's quite right.
Yeah.
And one of the other things that is really interesting, and a surprise that came back from the earlier missions to Mercury, is that it has a big iron core. Its core is bigger in relation to the size of the planet than any of the other rocky planets. So it's got an iron core, which gives it a significant magnetic field. But the magnetic field's curious because, unlike the Earth's magnetic field, which is basically centered on the center of the planet, the magnetic field of Mercury, if you imagine it, being replaced by a bar magnet, that magnet would be about 20% of the way from the center of the planet to the edge. It's not in the middle. That's
okay.
a bit.
So she's a bit wonky.
Asymmetry, yes. Mercury is wonky. That's right, and that's one reason why, why the magnetospheric orbiter will be doing its thing to try and map out and determine more accurately the size and shape of Mercury's magnetic field.
Okay, so lots to learn, and I love these longitudinal missions because we talk 7 years away, and then all of a sudden we'll get a news report saying, and blah, 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 Giuseppe Colombo mission has arrived at Mercury. And I'll go, already? Wow.
Where did the last 7 years go?
Because right. We'll forget about it, and then it'll be on the news again.
It'll be on the news again, yeah, that's right.
But this should be a lot of fun. So we will definitely keep an eye on this one. And there'll be lots to learn from Mercury. You're listening to Space Nuts with Andrew Dunkley and Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments, and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works.
So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, I'm not sure if Donald Trump is behind this story, but it sounds like fake news. But it's being reported by the highly credible source, the BBC, and probably several others, that a Chinese company has announced ambitious plans to put a fake moon into space to brighten the night sky. This is a country that is blanketed in pollution. So
that's true.
One wonders if that's the reason. But are they for real?
It sounds a bit like a beat up, really. The orbital mechanics of this sort of thing don't always work the way you might think they do. But let's tell you what we know. And yes, the BBC is one of a number of outlets that have reported this, but it's actually coming from an article in the People's Daily, the state newspaper itself in China.
Oh, well, it's true.
Which reports that there's an aerospace institute in the city of Chengdu, which the institute has announced plans that they want to launch illumination satellites by 2020 that are bright enough to replace street lights. It's
Gee,
the
BBC.
BBC.
That's a big call. However, the Russians did do this.
They tried it, but it didn't work.
Oh, I thought they had some success.
I thought, well, maybe they did, but I think it only lasted half an hour or something like that. And of course, it's to say outright that launching anything like that is designed to illuminate the Earth's surface it immediately raises questions about light pollution and things of that sort, which is very much an area of growing concern among, everybody, not just astronomers, but the medical profession, but biologists, botanists, people worried about insects being fooled into not pollinating crops and all of that sort of stuff. That is all now part of the province of the issue of light pollution. So it's bound to create a lot of raised eyebrows, but it's not straightforward. I like the BBC's comment, which says the following: the straight out of sci-fi news has sparked fascination, skepticism from scientists, lots of questions, and outright mockery. So that kind of more or less sums it up. It is a person who is the chairman of a company called the Chengdu Aerospace Institute Microelectronic System Research Institute Company Limited. That's their name. So there's two institutes in there, which is pretty interesting. But the chairman is a gentleman by the name of Wu Chengfeng, and he says basically that there's been a lot of tests on the idea of putting some sort of mirror in orbit in order to illuminate the surface of the Earth in the area of Chengdu. Now, of course, you can't just do it with one mirror because you need several in order to provide any kind of constant coverage. You know that at the height of 500 kilometers, which is what they're talking about, that means that you've got an orbital period around the Earth of something like 90 minutes. So the spacecraft only passes over the area that you're interested in for a very short time. It's overhead for maybe 5 minutes at the most, and then you've got to wait for it to come around again. You can do it actually in such a way. There are certain orbits, they're called sun-synchronous orbits, where the spacecraft passes overhead at more or less the same time each day. But it's still very messy. You're not sort of floating something in space that is always going to be beaming radiation down to the Earth. The only way you could do that, of course, would be to put it in a geostationary orbit, like the like the satellites are, but that's at a height of 36,000 kilometers. And you can imagine the size of the mirror you'd need to get any sort of light back from that sort of distance. Spacecraft at that distance are virtually invisible, except with very large telescopes.
I know they could use my wife's makeup mirror. It's enormous.
I'm not going to go there, Andrew, and I don't think you should either.
Too late.
But
I mean, we're mocking it a bit, and all the news outlets are having a bit of fun with it. And I do love the caption on the photo of the moth that says, "Has anybody thought what another moon would mean for moths?"
Yeah.
I mean, it sounds like a line straight out of Hitchhiker's Guide to the Galaxy. It's beautiful, actually. But theoretically, this is possible.
It's possible to do it, but it doesn't really, it doesn't kind of solve the problem. You're never going to have something that will mimic the moon. The moon's at a distance of 380,000 kilometers and behaves in a very straightforward way. But the idea of using something in low Earth orbit doesn't really work. You're quite right about the Russians having tried it. It was back in 1993. Yeah, 20 meters
1993,
wide.
there it is.
Yeah, and that was in low Earth orbit. And the idea was to beam a light spot down to Earth. Of course, that light spot travels across the Earth's surface at the orbital speed, which is 8 kilometers per second. And then this thing, well, I don't think it actually worked terribly well.
It did blind a kid on a bike who fell into a ditch and killed a deer.
There's probably something like that, yes.
I don't think so.
But I suppose the nearest realistic thing that we've got to this, and I'm sure you've seen these. There has been in orbit for a number of years, well over a decade, a fleet of spacecraft called Iridium. And the Iridium spacecraft, I think there were 66 of them. They're communication spacecraft. They're in a fairly low orbit, but each one has 3 antennas on it, which basically are polished mirrors. They're like large wardrobe mirrors, and they're all angled downwards. And when one of these things catches the light of the sun and reflects it down to where you're standing on the Earth, you see a spot of light which is probably 1,000 times brighter than the planet Venus. It is very bright.
Wow.
For a brief period of time, a matter of a couple of seconds. And so it's been, a bit of a hobby among sky watchers to look up in the tables. And it was very easy to find when there will be what's called an iridium flare, and go outside with some unsuspecting mates and say, just look up there. And instantly, this thing appears and flashes by. It's very impressive when you see. There's
you see the effect when you're flying and you look down and you see glints of light coming back at you that's reflected, the sun reflecting off water or something like that, or glass.
And things. That's right. It's the same sort of thing.
Yeah.
With the iridium flares, it was really quite spectacular because, of course, this was in the darkness. The iridium, those iridium spacecraft are now being replaced, and I think very soon there won't be any of those original Iridium spacecraft left, and the new ones that have replaced them don't have the reflective mirrors, so that little hobby has now gone by the board. But that was an example of this kind of thing, of reflecting light spots down onto the surface.
It was fun for geeks for a while, wasn't it?
Yes, that's right.
Yeah. Now they're talking about this mission launching in 2020, and are we taking it with a grain of salt that it probably won't happen?
My guess is it won't happen. I think if it got anywhere near, there would be sort of major public outcries. There's already a quote on the BBC webpage from John Barentine, a chap that we know quite well, who's with the International Dark Sky Association, and he's basically saying, it's a bad idea, as you'd expect, because it's light pollution, and you can't, you can't control it. It's hard to see how it would work, and it's certainly hard to see how it would save street lighting, which is what they're saying it will. The China Daily, one of the other news outlets in China, quoted Mr. Wu, the gentleman who was the chairman of this company, saying if you could illuminate an area of 50 square kilometers, you could save something like 173 million US dollars a year in electricity charges. But of course, you can't. You can only do it for a short time. It's
Probably
it's
cost
not,
you $173 million to send the thing up there anyway.
well, yeah, that's right.
Well,
So we'll wait and see. We will wait and see what happens.
they might surprise us. Who knows? And if your girlfriend sees that glint in your eye, just say, "Oh no, that's just a fake moon. Fake moon. It's nothing to do with me."
I'm not going there either, Andrew.
You're listening to Space Nuts. Andrew Dunkley here with Fred Watson there.
0G, and I feel fine.
Space Nuts.
Now, Fred, to finish off this week, we've got a couple of questions. First of all, and thank you for sending them in, and to everyone who writes to us. This one's from Michael Carey. With the failure of the rocket to deliver a new crew to and take a returning crew from the space station, isn't there an emergency escape module there that could take the remaining crew back to Earth if needed? How would that work? We're talking about that mission the other day that lifted off and something went dreadfully wrong and the crew basically had to bail. And they didn't get to the space station, and the people up there have run out of toilet paper. It's hell in space. It really is. But on the serious side of things, it could have been a dreadful disaster. But they all got away, which was the good news. But yeah, what's the story with a backup plan? Is I guess what Michael is asking.
Yeah, so Michael's absolutely right. That yes, there is a module there. There's always a Soyuz spacecraft docked with the International Space Station. Which is the lifeboat, if you like. It's what will take you back to the Earth. It was actually depicted in the movie Gravity that there was one of those. If you remember that scene where
That's right.
Yeah,
yes.
piled into.
So there
anyway,
was at least one thing accurate about that film.
That's right. That's correct. So when a crew goes up to the space station, this is the current way that it works, because it's going to change when the new SpaceX Dragon modules start being used for human transfer up and down from the space station. But at the moment, it's a Soyuz. The crew that comes up, the replacement crew, comes up in a Soyuz spacecraft and goes back down again in the old one, the one that brought the previous crew up. So that there's always a kind of fresh, fully fueled up, fully equipped Soyuz spacecraft waiting up there should there need to be a return to Earth.
Right.
Now, at the moment, there are 3 astronauts on board the space station, and the Soyuz is a 3-person spacecraft. But the full complement of astronauts on the space station has been 6. And that would, of course, require 2 Soyuz spacecraft to be there. And to the best of my recollection, that was always the case. There were 2 on standby.
Or 6 midgets.
That's right. It's a bit hard to get. I mean, you should see inside those things. There's not a lot of room.
No.
The other thing about these Soyuz spacecraft is that because they're re-entry modules, they're pretty tough. And so on a number of occasions when there has been an alert for space junk that could collide with the space station, what they've done is evacuated the astronauts into the Soyuz modules, just because that's a hardened area where space junk would find it harder to penetrate. Of course, if you want to drill a hole in it, that's a different matter. That's still
that controversy remains unsolved, does it not?
We don't know what the answer to that is yet.
Okay. So yes, Michael, there is a backup plan, and so they still can get back to Earth and get some fresh toilet paper and whatever else they need. Probably some body spray. Probably.
So Andrew, have you talked to anybody about this fascination with toilet paper?
It's just, I've actually interviewed a couple of astronauts, and I do actually ask the audience to ask them questions, and they always go to the toilet.
That's what you get.
They always go to the toilet. It's not me. This is audience requirements.
All right. Okay.
Yeah. How do you go to the toilet? Oh gosh, here we go again.
Yeah.
I think Andy Thomas, the Australian astronaut, I'm pretty sure he's sick of talking about how you go to the toilet. I want to know how Neil Armstrong went to the toilet. I think they just pooped in the suit. But
more or less, that's right.
Yeah, these days it's a little bit more human. But okay, thank you, Michael. Now we're going to move on to our next question from Scott Kime. Fred and Andrew, I want to start by saying how much I enjoy your podcast. Oh, thanks, Scott. Well, actually, we're going to change it now. I listen to it every week. You guys talk about all the stuff that I find fascinating about space. Well, there's one, Fred. I'm an aspiring sci-fi author. Oh, so am I. Let's compare notes. And I have a couple of questions regarding asteroids for my book. If anyone could answer, it would be you guys. Here it is. Would it be possible to pull a close-flying asteroid into orbit around Earth? Would it be possible to force a controlled asteroid landing onto Earth without endangering the environment or life or kids on bikes? Another couple of questions. How would this be accomplished? And are we close to having these capabilities, or are we still a long way off?
Yeah, they're great questions. And I guess, as in so many of these things, the answer is it depends. Because what it depends on is how big an asteroid you're talking about. You know, and once again, there's this grey area between a large meteoroid, as it will be when it was out there in space. It's only a meteor when it hits the atmosphere, and a meteorite if it hits the ground. But a large meteoroid, maybe, 5 meters across, something like that. Can you count that as a small asteroid? I don't know. It's there's a grey area between the two. 10 meters, I would say, will be a reasonable cutoff for small asteroids. But even something 10 meters across has a huge mass to it. Yeah, because it's solid rock. It's much more than a 10-meter spacecraft. In terms of the mass that you're talking about dealing with. And so to change its velocity means you need a fair bit of thrust. So yes, you can imagine tying a rocket motor onto an asteroid, and that's certainly one of the solutions for altering the orbits of asteroids that may one day threaten the Earth, and there aren't any at the moment, at least not over the next couple of 100 years. But if we did find something like that, then fixing a rocket motor to it and giving it a thrust in a particular direction will be one way of changing the orbit enough that you could miss a collision. That's the whole idea of that. You probably need 10 years advance notice to do that, though, because the force you can apply to the asteroid, even a relatively small one, is small compared with the mass of the asteroid. And that's exactly the problem that that Darren's basically facing here. If you want to pull a close flying asteroid into orbit around the Earth, you've got to change its velocity by a lot, because you've got to slow it down to put it in an 8 kilometer per second orbit around the Earth, when it's probably going by at, well, it might be 20 kilometers per second or something like that. So if you've got a massive asteroid, you need a hugely massive propulsion system to do that. And I don't think we're anywhere near that at the moment.
This problem was actually portrayed in the movie The Martian, when they had to try and capture the astronaut when he got off Mars. And I think his initial speed was 42 meters per second, which would have made it impossible to capture him. So they had to slow the spaceship down by blowing the hull and air braking, basically.
I remember that, yeah.
And they got their speed down to something like 12 meters per second, or some manageable figure. He ended up doing the Iron Man thing anyway, and that sort of took it beyond the realms of likelihood. But this is a completely different prospect, catching a person versus catching a massive rock.
Yes.
And even if you could, what would you do next to get it inside the atmosphere and on the ground softly? Because once you get inside the Earth's atmosphere, gravity takes over, and the damn thing's as heavy as a rock.
That's right. You'd have a re-entry. So the other part of Darren's question is, would it be possible to force a controlled asteroid landing onto Earth without endangering the environment or life? At the moment, we just don't have the technology to do that, because, and again, it's all about the amount of thrust you'd need to slow it down and to bring it down with a controlled re-entry. It's, when you think about a spacecraft re-entering the Earth's atmosphere, like the Soyuz, they come down, they are slowed by the atmosphere itself. There's what's called aerobraking, which is the friction of the atmosphere slowing down the spacecraft. That makes it very hot. But the last, the final few kilometers or few hundred meters is on parachutes. Now, parachutes and asteroids don't sort of really scan in the same sentence. So I think we are a long way from that kind of technology. Maybe a science fiction writer could think of possible new technologies that might allow that. But for somebody whose feet are based on 19th century engineering, it doesn't look like a good prospect at the moment.
So there you go, Darren. Probably not in the foreseeable or maybe even the long-term future. But let me give you a little bit of advice about science fiction. It's science fiction. You can do whatever you damn well like.
Yeah, that's true. That's absolutely.
Don't let that stop you. Don't let facts get in the way of a good story. There's the journalistic mantra, if I may. So,
which you've followed faithfully all your life.
Go for it. Yeah, true enough. Just like the story about the fake moon. Yes, Darren, and thanks for your question. And sorry, I got your name wrong. I called you Scott. That's your middle. No, I'm saying you're probably hyphenated, aren't you? Darren Scott Keim. Nice. All right, Darren. Good luck with the novel, and let us know when it's out, because I will get a copy as long as you buy mine, which is due out next year. We'll see how that goes. And thanks to who was it, Michael, as well, for his question. And thank you to everybody who contacts us, even those that just write to say hello or send us a video or a picture or something like that. We really do appreciate it. And thank you, Fred, as always. It's just great fun, and I think everyone's getting a big kick out of it.
It's a great pleasure, Andrew. So am I. So we'll speak again next week, I hope.
We will indeed. Fred Watson, astronomer at large, and from me, Andrew Dunkley, thank you again for listening to Space Nuts. See you next time.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.